Hello, in this video we are going to look at finding all the zeros of a polynomial and then also factoring completely. And so a couple things. First, the rational zeros theorem talks about how to find possible zeros. So this is a good starting point. So they're all in the form p plus or minus p over q, where p is the factors of the constant, and then q are all the factors of the leading coefficient. And we'll just use LC for leading coefficient. Okay, so what does that look like practically? This is a very shortened math definition. So if I want to list all the possible zeros of this polynomial, possible rational zeros, then I have 12 and -6. And so I'm going to list them as plus or minus, and I'm going to get in the habit of doing this P over Q. But what we're looking at is the factors of 12 over the factors of 6 in every combination of that. So one way to write it out, we'll just keep this plus or minus, would be the factors of 12 are 1, 2, 3, 4, 6, and 12. So these are numbers that multiply into 12 or divide 12 evenly. And then we have 1, 2, 3, and 6. Okay, so this means, what does this mean? It doesn't tell us anything exactly, but it tells us the possible rational zeros. So those are like the ones that can be written as a fraction or integer, are 1 over 1, 1 over 2, 1 over 3, 1 over 6. So for every single one of those, it just be 1 over 1 is 1, plus or minus 1/2, plus or minus 1/3, plus or minus 1/6. Okay, and then, but there's other options. So then we have 2 over 1 and 2 over 2. So we have plus or minus 2. 2 over 2 we already have, because that's 1, plus or minus 2 over 3. And then 2 over 6 is 1/3. And so you would go through and list every single possible zero. So possible rational zero. So we'll go ahead and do this. We have plus or minus 3, plus or minus 3 over 2. I wish I would have picked a shorter example. 3 over 3 I already have. 3 over 6 is 1/2. Go on to this next line here. Plus or minus 4. 4 over 2 is 2. We already have that. 4 over 3. 4 over 6 is 2/3. Plus or minus 6. We already have 6 over 2 is 3. 6 over 3 is 2. 6 over 6 is 1. And then plus or minus 12. 12 over 2 is 6. 12 over 3 is 4. 12 over 6 is 2. So we already have that. So these are all the possible zeros. Okay, so then to check if they're actually zeros, you can do one of two things. You can either just guess and plug each value into f of x and see if you get 0, or you can look at the graph. And this is what I would recommend. We have enough graphing technology in our day right now where you can either use your graphing calculator or go to desmos.com, and you are looking for x-intercepts. So the x-intercept are zeros. And we'll do that later here in this video. A couple things first. So the factor theorem says if a is a 0, then x minus a is a factor. And this is a very important relationship to know. If you know a 0, then you can find a factor. If you find a factor, then you can find a 0. The fundamental theorem of algebra says a lot of things. In short, the number of zeros is equal to the degree of the polynomial. And so even if we go back up here to this one, this is going to have 4 zeros. They're not necessarily going to be distinct, meaning all different, or all real, but there's going to be 4 zeros. Okay, and let's look at some more math stuff really quick. So talk about complete factorization. This is when everything is factored down to linear factors. So we have the big thing. This is pretty confusing, I think, and pause and work through some of this definition. The big thing is that you can always write it where it's x to the first and then minus a number, plus a number, whatever it would be. So it's always x to the first minus the 0. And so what this means, and this includes complex factors, is now we can factor with i's. So we can do that. And we're going to use division, specifically synthetic division is what we use to help us factor if we can't factor other ways. So we'll get some good factor interview in with these problems as we find the zeros and then find the complete factorization. So notice on all these, we're going to find all zeros, state the multiplicity of each zero, and then write the complete factorization. Okay, so the first thing to do would be to, and then we want to find possible zeros too. And we're not going to list all those out specifically. We'll keep the shorthand form. So the possible zeros, this would be the factors of 16, 1, 2, 4, 8, and 16, and then over the factors of 1. Okay, and that's far enough on the possible zeros. Probably that's probably right. Possible. Okay, and then the next thing you want to do is see if you can factor this. Okay, so this we can factor. This is a perfect square trinomial. So I could factor this as x to the 4th plus 8x. Well, I guess I'm just rewriting it. But two numbers that multiply to 16 and add to 8 are 4 and 4. So this is, I'm going to put it over here, x squared plus 4 times x squared plus 4. So this is my perfect square trinomial. And then to find the zeros, we know we set each factor equal to 0. And that's far enough. We can't factor anymore. This is far enough just to solve. So x squared plus 4 is equal to 0. It's the same, so you could write it again or just know that it's the same thing. So x squared is equal to -4, and x is equal to plus or minus 2i when you square root both sides. Okay, and this would give you the same thing. X is equal to plus or minus 2i. Okay, so now we can list all the zeros. So the zeros are x is equal to 2i and x is equal to -2i. They have a multiplicity each of 2 because they each occur twice. So there's a positive 2i here and a positive 2i here, and then a -2i, -2i. Okay, so if I wanted to list out all the zeros, and to do the factorization, I would do this. So the factorization, let's list them all out. X is equal to 2i, x is equal to 2i, x is equal to -2i, x is equal to -2i. And then to find the factors, just set each one equal to 0. So x minus 2i, x minus 2i, x plus 2i, and x plus 2i. And so there is the complete factorization of my polynomial p of x. Okay, here's one. The possible zeros would be, we use pz for that, plus or minus 1, 2, oh man, 4 is 15, right? Or 16. Four, and then 8, and then 16, 32 and 64. So a lot of possible zeros all over 1. And so we could go through and double check or check this by plugging in values here. You could also go through, or you could also factor this as a difference of cubes, but not a lot of people remember that. So let's go to the other option. Let's look at the graph. So if you graph this, which we'll try to put the graph right here, you can see that the x-intercept happens at 8. So we can see that the x-intercept is 8. So that means, or no, not 8, sorry, it would be 4. So x equals 4 is a 0. That's where the graph goes through the x-axis, according to this graph. Okay, now we can get rid of the graph, but because there should be 3 zeros and I only see 1. And to find the other 2, you're going to use synthetic division. So 1x cubed, 0x squared, 0x, and then negative 64. And you bring the 1 down, and then multiply across. So we get 1 add 4 add. Okay, let's go back. This should be, so at first I noticed my error because I should get 0 and I don't have 0. So let's go back. This is 4 times 1 is 4. So then that should be 4, and that makes this 16. And then that makes this 16, which makes this 64, which makes this 0. So if this is 0, that means this was a 0. So now I have a factor. I have x minus 4. That comes from moving this over. And then everything else, or what I'm left with, is this. So this is tricky, right? But this polynomial can be factored like this. Okay, well now how do I find the zeros? Well, I can set each factor equal to 0. I try to factor this, but it does not factor. So x minus 4, that gives me 4. I can use, if I set x squared plus 4x plus 16 equal to 0, then we have to use the quadratic formula. And so yes, this does take a little while, but that's just the nature of the problems. These are long problems. Negative b is negative 4 plus or minus the square root of b squared is 16 minus 4ac all over 2. And then I always recommend doing this all in your calculator at once. You get negative 48. And then we can reduce that. 48, you can take out, let's see, a 16. And so that's 4. And the negative brings out an I. And you're left with square root of 3, because 16 times 48, or 16 times 3 is 48. And then this is all over 2. And then this reduces to negative 2 plus or minus 2i square root of 3. Okay, so these are zeros. X equals 4 is a 0, and negative, let's write them out. X equals 4. X equals negative 2 plus 2i squared of 3. And x equals negative 2 minus 2i squared of 3. So we found all our zeros. Now we're going to go back to this simple idea, but very complex, of finding the factors from that, which is just move each of these to the other side. So your factors would be p of x is equal to x minus 4, and then x plus 2 minus 2i squared of 3, and then x plus 2 plus 2i squared of 3. So pause the video and make sure you can figure out where these zeros come from and then where each of these factors come from. Okay, and this is one I want you to try on your own first. So pause the video, give it a try, and we'll see how you do. So the first thing, you can list all the possible zeros. So that's plus or minus 1, 2, 5, and 10 over 1 still, because the factors here are 1. And then we look at the graph. So let's look at the graph. Hopefully it comes up right there. And we can see that x equals 5 and x is equal to -2. Those are both zeros. So we're going to use synthetic division. Let's start with 5. It doesn't matter which one you start with. So 5 goes in the box. And then bring down the 1. We get a 0. We get a 0. -5. See -25. And then add them. -2. 10. So I'm going through the synthetic division fast. So if you need to pause and try that, good. And then x equals 5. So let's make this x minus 5 for my factor. Excuse me. And then this was x to the 4th. So this becomes x cubed. 0x squared minus 5x minus 2. Okay, now I'm going to use this, and you can even use these numbers here. I'm going to use this to bring down and do synthetic division with my -2. So we have -2, and then 1, 0, -5, -2. Be sure you don't start from the beginning. You're going to divide what's left. So then this gives you 1, -2, -2, 4, -1, and 2. And so now look at what you have. You have your x minus 5 still. This gives you x plus 2 for a factor. And then you have x squared minus 2x minus 1. Okay, but once again, this is something that you cannot, well, actually, nope, this does not factor, but you can solve it with the quadratic formula. So let's see, we're going to squeeze that in over here. Actually, let's put it up here. So we have -b, which is 2, plus or minus the square root. B squared would be 4, minus 4, a is 1, and c is -1, all over 2a, which is 1. This time you get +8, which can be reduced to 2 square root of 2. So they get square root of 4. Which again reduces to x equals 1 plus the square root of 2, plus or minus the square root of 2. Okay, so we don't, all of our zeros have a multiplicity of 1, but our zeros are x equals 5, x is equal to -2, x is equal to 1 plus square root of 2, and x is equal to 1 minus the square root of 2. So these are all the zeros. There's 4 of them, which you expect because the degree is 4. And then the factors would be x minus 5 times x plus 2, and then move this stuff over. So x minus 1, minus 1 minus square root of 2, and then x minus 1 plus the square root of 2. So here are the zeros, and here are the factors as I run out of room to do that. So what's interesting is this, and ignore this parenthesis here. All of this is equivalent to this. It is just the factored form. If you want to graph both of those in Desmos, you could see that. Okay, the last thing we'll talk about, and we'll kind of do this briefly, but the conjugate zero theorem is says if a plus bi is a 0, then a minus bi is a 0. And you can kind of see that with the last two examples because we always have this plus or minus here. And so like on 6, if I given the zeros, it says degree 4, there should be 4 zeros. So if the 0 is x equals 1 minus 4i, then I know automatically it's also telling me x is equal to 1 plus 4i. And then x is equal to negative 3 has a multiplicity of 2. And then to write that as a polynomial, we just list out the factors. So I have x minus 1 plus 4i, x minus 1 minus 4i, and then x plus 3. We're going to square that. Last thing we got to address is this leading coefficient of negative 8. So just put a negative 8 there. Now, if I said it wanted it standard form, you'd have to multiply all that out, but you don't need to do that in this case. Okay, and then the last one, pause that and try to do that on your own. But list out all the zeros. And so when you write a polynomial, let's use f of x. I'm going to go ahead and include the leading coefficient up first. And then I'm going to put this x in the first one, even though I put my parentheses there. And then x plus 2 when I add over, x minus 2 when I subtract the 2, and then x minus 4. And good luck with this, and please reach out if you have any questions.